have up front, what we want everybody to see here is a simulated car charging system. We've got two batteries. We can connect either one or both. We have an alternator on a 1.5 horsepower motor down at the bottom, and that simulates the car. We've got the 1.5 horsepower motor to drive it. We've got a full system up here. We can connect one or two batteries. We can turn on amplifiers individually. We've got a headlight. We've got a blower motor. And we also have a capacitor we can connect to help the subwoofer amplifier if we need it. And what we're going to do is run through a lot of different configurations, and we're going to show you what happens when you connect different things and how it affects the charging system. And we're going to talk about each of the components first. Let's talk about batteries first, because there are a lot of companies here to sell batteries. And everybody needs a battery in their car, at least one. Why do you need the battery? Well, the primary function of a battery is to start the car. Once the car is started, ideally, the alternator should pick up the load for the whole system and power the whole system. If your alternator doesn't have enough juice to power a system, let's say you put in a multi-thousand watt amplifier and the alternator can't keep up, it will drop in its voltage and the battery will help pick up the load. But ideally, the alternator should power the whole system. Lots of different kinds of batteries out here, okay? But they're all lead acid batteries. You have the lead plates and you have the electrolyte which surrounds it. You have a positive post and a negative post. When you connect the load to the batteries, a chemical reaction takes place, which creates the electricity, the energy, to go through the load, power it, and when you disconnect the load, the chemical reaction stops. The normal set point voltage on a battery is 12.6 volts. 10.5 volts, your battery is 100% dead. At 10.5 volts, your battery is dead, SAE standards. If you take a battery down to 10.5 volts, recharge it, it'll be fine. It'll last you 3 to 5 years. All batteries should last you 3 to 5 years. But if you take a battery and you discharge it down to, well, let's say you leave your headlights or your dome light on overnight and the battery gets down to 1.5 volts, tie a rope around it, take it out on the boat and use it for an anchor, because that's about all it's worth. You can put a charger on and you can get it back up to where it'll show you over 12 volts, but it's a dead battery. It'll never be at 100% capacity. So if you take care of your batteries, it will last a long time. Different types of batteries. You have the deep cycle marine batteries, the quick discharging starter batteries. You have some of the absorbed glass mat batteries. You know, you've got Kinetic and Excess Power and a bunch of different companies making really good quality batteries. They're all lead acid batteries, but they work in a different way. A deep cycle battery has fewer, thicker plates. There's less surface area for the chemical reaction to take place. With less surface area, it cannot discharge as fast or recharge as fast, but it can discharge for a much longer period of time. You can discharge for a longer period of time, and if you're sitting in the parking lot with one of those batteries, you can listen to your system longer. A starting battery has more plates, but they're very thin. There's more surface area for the chemical reaction. Much higher current discharge rate, however, you cannot discharge them as long before they're dead. You can also recharge them faster, so there's trade-offs to using either or, and there are the hybrid batteries also, which are kind of in between. If you want to know more about batteries, you can talk to the specific manufacturers, but that's enough of what we're doing here.